Okay, I welcome you all to the live interactive session for solving the problem in the week 2 in the course Water Society and Sustainability. And this course is being taken by Professor Jena Mukherjee. And I am your TA, Aman Srivastava. And in this session, we will be focusing towards season-wise water budgeting. But before we start season-wise water budget estimation, let us revise what we studied in the last week. So yes, in the last week, our objective was to find out the annual water budget, and there were four land uses in the village that we considered: forest, agriculture, built up, and lake. And we categorized all the hydrological phenomena into rainfall, storage, and losses. However, a big question is there as to whether to call it as losses or not, and there are different school of thoughts behind using this terminology that we are going to clarify in week 2 lecture. And then we end up with this equation where the storage, and if losses are removed from precipitation, then we are left, or rainfall, then we are left with surface runoff. And we saw one sample calculation for agriculture which yielded 602.9 thousand cubic meters of water, which were converted as surface runoff. I hope that other values you must have tried by yourself. Very soon NPTEL will upload the week 1 video. They are taking bit time, and once you will once you will visit, once you will see all those videos, then you will try to find out all the other values that we have estimated, and there is a simple calculations that we used to derive all these values. Some of the observations that we recorded from this table and in general through discussions is that there is a high surface runoff recorded, as we can see: 68% for forest, 65%, 81% for built up, and 33% for lake. Someone is knocking, let me invite. Okay, moving ahead. So these were some of the recommendations that we came up with, such as to solve the problem of water scarcity, attention should be given to harvesting the surface runoff, and for which we come up with some of the provisions such as establishing farm ponds in agricultural land use, or bringing rainwater harvesting scheme in built up areas, or establishing check dams in barren lands. Also, we look forward for desiltation of the lake, with this assumption that must be, since it is the place was maybe undergoing soil erosion, and there must have been silt deposition or soil deposition due to the high surface runoff, which all will be deposited in the lake, as a result of which the volume of the lake must have been compromised. So we came up with one solution, that why not to look forward for desiltation of the lake as well. But all these solutions are coming up by looking at some of the data that we were having and the analysis that we conducted. One of the suggestions that came from week 1, which I have now added here, is the enhancing groundwater infiltration scopes to recharge groundwater aquifers. So yes, but one more important thing is, when the problem statement was defined for week 1, it was more or less assumed that the village is not much developed with regards to having sources to extract groundwater, and mostly it was realized that the agricultural practices were mostly rain-fed, and there were no other irrigation sources available specifically for doing agricultural practices in the village area. Yes, although we have lake, that is one of the storage, but again we realized from the week 1 problem statement that the application of lake for agricultural practices was also not is not much synchronized. But surely groundwater infiltration is one of the processes which helps us to recharge groundwater resources, but we are unaware for the present case study whether there is ample groundwater availability in the village, because this requires separate investigation. And maybe because we are now technocrat come policy maker for this investigation, so we are not having that much time to explore groundwater resources. Maybe that can be one of the scopes, future scopes. But currently whatever is available in the village with regards to storage, with regards to the amount of rainfall which is received in on each of these land uses, within which we will try to find out and come up with some recommendations for better water management. So this was something that we revised from week one. And yes, we left week one with this question that although we have taken into account the water budget at annual scale, where all the 12 months were taken into account, however, we all know that how spatio-temporal disparity exists for rainfall, such that it is not uniform throughout the year. So that helped us to revise our objective to estimate seasonal water budget instead of annual water budget of a typical Indian village based on the learning from week 1 and 2 lectures and revised recommendations for management. So we already recommended or we came up with some of the recommendations in the village based on the annual water budget. But now our focus is more towards seasonal water budget. Okay. So, if there are any doubts from the week one discussion, you may please put forth. Otherwise, we will start solving the objective number 2. Anyone? Okay. So good to go for solving objective 2. So now our focus for the today's live interactive session is to find out seasonal water budget. When I say water budget, that means we wanted to look how much water is available as a storage, how much water is available from storage for supply, and how much is the water demand, and whether there is a synchronization between supply and demand. So this is what we are looking forward when we say water budget. And gradually from week 1 to week 2, we are further digging up into precisely estimating water budget. And based on the findings from water budget, we will be coming up with some solid recommendations for water management. Same as week 1, we will be having focus on climate change as a planetary boundary framework. We will consider water as a resource to be managed, controlled, and hence to be quantified. Definitely social hydrology, political ecology, and hydrosociology of water conceptions will be taken care. So wherever when we are describing some problem or when we will be solving the problem, we will look into how these conceptions can be accounted while designing the problem or while designing the solution of the problem. So that should be there in the subconscious mind, and subsequently we will take the help of all these very important conceptions of water resource management. Surely transdisciplinary approach will be considered rather than merely a disciplinary approach. For example, if we look forward to solve the problem merely with the help of humanities and social sciences, we may come up with some solutions. Or if we try to solve a particular problem merely with civil engineering approaches, then we may come up with some solution. But we are looking forward for holistic solutions. So we need to take the help of multiple disciplines such as civil engineering, agricultural engineering, humanities and social sciences, etc. And that's why, with the help of these understanding, we would like to advance the science of hydrology for the benefit of society. So here, our society is the rural village, rural communities, and there are many stakeholders such as farmers, women, school-going kids, and many institutions in the villages such as Sarpanch office, Jila Parishad school, Anganwadi, etc. And altogether, if we wanted to have these assumptions in right place, we need to integrate them as well, because definitely one proposition supports other or paves way for bringing other solutions as well. So that lead us to integrated water resource management framework to be considered while arriving at any of the solutions. So no one solution can solve the problem, but group of solutions can really help us to come up solving major portion of the problem in the village. So Any questions until here? Any questions? No? Okay. So,
No, sir.
yes. No questions. Okay. So now, yes, now we
Yeah.
have a different objective. In the week one, our objective was on annual water budget, but here now objective is changed. Now we are looking for seasonal water budget. Definitely, this will catch our attention to revise the problem statement. So this is the revised problem statement now in front of us. You are a technocrat, come policymaker, investigating a village since last week. Okay, so we have joined this course or this interaction since the last week. So yeah, from that time only we have been investigating in this village, which is located in the semi-arid region of East Maharashtra. Just to revise, we are in a region where rainfall is plenty. However, the management of the plenty rainfall is somewhere missing, and that's why despite having this much rainfall in the East Maharashtra region, which is usually Marathwada or Vidarbha, the region is still classified as semi-arid. You were told that the village is witnessing water scarcity problems during non-monsoonal seasons. So when we say non-monsoonal seasons, it means that it is a non-rainy season. And in our country, the rainy season is mostly in June, July, August, September, as per the India Meteorological Department classified season. North and the monsoon season is also called as southwest monsoon. You identified, utilizing the following data, that excess surface runoff could be an issue which requires harvesting or which requires to be harvested. So this is the finding that is coming up from annual water budget. So now we are having this information as well, that one of the reason, one of the plausible reason for water scarcity problems could be excess surface runoff. When I say excess surface runoff, it means that a major portion of rainfall is contributed as runoff from the region, or which is flowing away from the village area and which is unutilized basically. And these were some of the findings, or some of the considerations that we took into account while solving the problem for week one. So we know that the area of our land uses, such as forest, is 30 hectare, built up is 25 hectare. So and we can see that the major area is under agriculture, 35 hectare, which indicates that the village is agricultural dominant village. Rainfall, as usual, it was 2650 mm, and storage corresponding to each of the land uses are different. We find that maximum storage is occurring in lake, because lake is a surface depression that allows for more scope to store rainwater. That means 53% storage can be possible in the lake. And these are some of the losses. When I say losses here, so from civil engineering, from purely civil engineering point of view, these losses here means all those water which could not be utilized in the current scenario. So that included evaporation, evapotranspiration, groundwater infiltration, and many other such kind of losses. But as we discussed in the previous week as well, and emphasizing the same thing again, let's try to refocus on utilizing the term called losses here, and look forward for finding some more a very relevant term that can help us to make it sensitive enough for the current situation. So this was the demonstration of the village, where at the most upstream we can find forested land, which is one of the land use, followed by built up area, and then we also know that this village is agricultural dominant village. So we can find major portion of land, that is 35 hectare, as agricultural land use, followed by lake. And now we can clearly understand that the flow of water is from upstream to downstream, that means from forested land use via built up to agriculture and lake. Right. So yes, as we were discussing from the engineering hydrology point of view, there is a water budget equation, or water balance equation, or hydrological equation, which is indicated as rainfall minus storage minus losses is equal to runoff, where we have defined losses as this. But but from knowledge of social sciences of hydrology. These losses are nothing but it is unutilized water. Now we see here, and it was also suggested in the last week that can we come up with some alternative word than losses? And yes, here is one alternative word which is unutilized water. When we use this term unutilized water, it gives us a sensation that there is a scope, there is a hope as well for utilizing this water. So this is the water which is being unutilized and which run off from the study area, that is the village boundary, and that's why we are revising our equation from engineering hydrology point of view to social science of hydrology point of view, that is P minus S minus U, where U indicates unutilized water is equal to surface runoff. I hope that we have now resolved one of the issues that we were facing while understanding the problem statement and while developing the solution for the case. So now the losses has been replaced with unutilized water, and we are now hopeful that we can find out ways to utilize this unutilized water. Any questions at this point?
No, sir.
Oh, thank you. Moving ahead. Yes. Now we are further elaborating our problem statement. Now for second week, your objective to identify the preliminary reasons behind water scarcity considering the seasonal water budget of the village. So we are very much now clarified that what we are looking forward, it is the seasonal water budget. So now we have 4 seasons here. Winter representing January and February, summer representing March, April and May, monsoon representing June, July, August and September, while post-monsoon is representing October, November, December. So we see here that all the 4 seasons are giving us all the months, that is from January to December. There are other terms as well. For example, monsoon is also called as southwest monsoon or summer monsoon. Post-monsoon is also called as northeast monsoon. You can find out more information about Indian monsoon system from research papers. And yes, so now I would like to ask one question. Can anybody tell me what is the total rainfall received in the study region annually? Anyone? What is the total rainfall in which is received in the present study region?
I'll have to check, sir. Don't exactly remember.
No, we do not need to remember. In this table only the answer is there. I am asking,
Okay.
yeah, total annual rainfall. What is the total rainfall received in the study region for a year?
Total for which season, sir?
No, I am asking annual.
Or
Annual rainfall. Yes.
so this will be 20,
Okay.
2000.
How are you arriving? How are you arriving at 2000?
Yeah, sir.
I mean, you're trying to recall what we used, or you're looking at the table and trying to.
Hello. No, I was just going to add all those months: winter, summer, monsoon, post
Yeah,
monsoon.
please add and let me know.
Okay, so it's 2500, 2600, 2650.
Okay, exactly, and this is what.
Right?
Yeah, exactly, and here we have seen 2650. So in the week one problem statement, we were given that the rainfall was 2650 mm. But in the week 2 problem statement, we can clearly see here that we are having 4 seasons. So each season is having some rainfall, some magnitude of rainfall. So sum total it gives us 2650 mm. So this was a kind of realization that I wanted to give to all the candidates here, that this is how the 2650 mm of rainfall was received annually, of which major portion of the rainfall is coming in monsoon, which is 2000 mm. So now we can see here that rainfall is not uniformly distributed across each season. For example, in summer it is very nominal rainfall, which is hardly 50 mm. And I'm pretty sure that 50 mm rainfall is almost insufficient to give scope for agriculture. Even 100 mm is also not so good. 500 mm also is not much good rainfall for supporting agricultural practices, at least not paddy or water intensive crops. But only season which we have is the monsoon, where there are scopes for agricultural practices, which is 2000 mm. So you can imagine that of the 2650 mm of annual rainfall, 2000 mm of rainfall, that means around more than 90% of the rainfall is occurring in only one season, which is monsoon season. So we can understand here from this season wise classification of rainfall that the water availability and distribution is very varying, and again it demands our attention. That is being, we are, since here technocrat as well as policymaker, so it is catching our attention that since the water availability input is mainly limited to monsoon, so how we are extending or how we are storing the water which is received in monsoon in the other seasons. For example, if this is the rainfall which we received in the village, how are we ensuring that this, the major portion of this monsoon rainfall should continue until the next year's summer comes, where the rainfall will be very less or almost negligible. So this is a kind of challenge. Right. Now here when I say forest as, it is nothing but storage. So how much forest can store this rainfall? Here the percentage are indicated. For example, the forest can store 15% of monsoonal rainfall and merely 2% of summer rainfall. And we know that 2% of summer rainfall becomes even more less. I mean, if we find out 2% of 50 mm, it comes to be so negligible or insignificant that it is we can assume this as zero. So no rainfall at all in summer. So we can see here that the maximum storage for forest is possible only in the monsoon season, which is only 15%. And what is U? We have seen here that U is unutilized water. So how much is the unutilized water generated from the forest in the present study area? We can see here that the maximum unutilized water for forest is in the summer season, which is 35%. So now we have the clear understanding that in the summer season, which is the critical season here, rainfall is very less, storage is way too poor, and unutilized water, the unutilized water is very high. So summer is the season which we need to target. Likewise, the next targeted season could be winter, where we see that rainfall is not so high and storage as well as unutilized water is also not seems to be good with regards to having or continuing the another season of agriculture. For example, first season of agriculture we can imagine for monsoon season, where we can look forward for water intensive crops. But what about the Rabi season crops? For that, the scope is very limited here. Likewise, if we look forward for built-up region, how much is the storage possible in built-up region? We can see it is way too lesser than forest, because it is a concrete land, it is a cemented land, and such hard surface does not allow water to infiltrate inside the ground or does not allow water to stay in the built-up region. It is mostly converted into surface runoff. So these waters, so that's why the storage in the built-up is very less. And since the storage is less, we can now understand like why unutilized water will be very high, right? Because we cannot able to store that water. So that's why we see here that most of the water is becoming unutilized. And when I'm bringing this data, these are the data that were collected by the researchers who came to that village before you. But the only difference between the researchers who came to this village before you and you is that those researchers were completely technical. So that's why they are coming up with these statistics, this data. But we here are not only statisticians, we are not only hydrologists, but we are social hydrologists, or we are hydrosociologists, or whatever the way you want to put forth. But we are someone who is also looking into account the people, looking into account the humanities and social sciences point of view while evaluating the data that we are having here. So that's why we are actually re-investigating what the previous researchers in the present study region, in the present village, conducted and gave us the findings. If you look forward for agriculture, so here the storage in agriculture is again very less, like 0%. So we can see here that if no storage is possible in the summer season, then how can we imagine for having agriculture during these critical seasons Even in the winter is also very 5, it's just 5%. So and in the monsoon, which is the peak season for having kharif cultivation, we see here that the storage is merely 25%. So one thing that we can realize here is that the topography of this region is not much supportive, because despite having this much huge rainfall, we are unable to catch this water, catch this rainwater. So definitely we are learning from this table that somehow the unutilized water is significant. Somehow we are unable to store that water significantly, and these all informations are indicating that the surface runoff from the study region, that is the village, is very high. Likewise, if we look forward for lake, which is the only structure available in the village that intends to harvest surface runoff or rainwater, we find here that some hope in the lake. For example, 90% of the rainwater can be captured in the lake. And during the post monsoon, 70% of that rainfall. But we know that in front of 2000 mm, 500, 100 or 50 is almost negligible or insignificant. So our only hope for improving the water resources in the present village is focused or is dependent on the monsoonal rainfall. And also, if this monsoonal rainfall which is being received is not utilized properly, it will result in acute water scarcity. And now we can actually come up with the findings like why water scarcity issues are persisting in the village, because there is no management available in the village that can help us to not only utilize monsoon water during monsoon, but also utilizing the monsoon water during non-monsoonal seasons such as post-monsoon, winter and summer seasons, respectively. Is this table clear to everyone? Is my voice audible?
Yes, it's clear for me.
Okay, thank you. Let me admit Madhur Goel. Yes. Okay, moving ahead. Now here comes the calculation part. And this is very easy calculation, because we should not be afraid of this numbers at all. It is a very easy calculation because now we have a clear understanding, not only from week one but also from the data which we received just now for different seasons, and what are the values of each of the variables that we are having, or sorry, particulars or land use that we are having. So we find here that rainfall is the input, and based on the different land uses, the characteristics of land uses are defining how much is the water that we can store or how much is the water which is unutilized. Now, what we are supposed to do is to utilize this in these three informations, like rainfall, which is the input, and storage, which represents the storage in the study region, and unutilized water is some water which is not being utilized or not being stored. And it is also not that water which is becoming surface runoff. So let us solve for agricultural land use. So here we are having the data for agriculture, right? So we are focusing on winter. So please be with me. We are looking at winter season for agricultural water budget. So we are actually calculating seasonal water budget for the season winter for agricultural land use. So here it is given that the storage is 5% of the total rainfall, which is 100 mm. So let's see here. So land area was 35 hectare and magnitude is 100 mm. So how much will be the rainfall volume which is being received? So we know from the week 1 lecture as well that here 35 hectare has to be converted into meter square. 1 hectare is equal to 10,000 meter square. We need to convert 100 mm rainfall into meter, which is nothing but we have to divide 100 mm by 1000 to make it meter, and then we get the answer in 1000 cubic meters. We divided this further by 1000 and we got 35,000 cubic meters of rainfall received on agricultural land during winter. Now, of this rainfall, 5% is storage, as we have seen here. Storage is 5% and unutilized water is 15%. So we can see here 5% of 35 TCM and 15% of 35 TCM, where 35 is nothing but the amount of rainfall received during winter season for agricultural land use, which come out as 1.75 TCM for storage and 5.25 TCM for unutilized rainwater. Now we know that our primary equation is this: rainfall minus storage minus unutilized water gives surface runoff. Now let's try to find out what is the surface runoff for agricultural land use during winter season. Substituting the values of P as 35, S as 1.75 and U as 5.25, here we obtained the surface runoff as 28 TCM. It is clearly observed here that of the 100 mm of rainfall, or of the total 35 TCM of rainfall, 28 TCM is becoming surface runoff. Of 35, 28 TCM. So we can see here that merely 7 TCM of water is being available, that we can actually look forward for utilization. Similarly, we can do that same calculation for summer season. Summer represents March, April and May. Now we know that the agricultural land use will not change. It is constant 35 hectare. But magnitude of rainfall has decreased. In winter, it was 100 mm. In summer, it is 50 mm. So doing the same calculation, here we found that the amount of rainfall received is 17.5 TCM, of which storage, which is possible, is 0%. So we know here that in the summer season, agricultural storage is 0% and unutilized water is 35%. So we have used this information here: 0% storage and 35% water, and they are yielding these values. Substituting all these three values in our primary equation, P minus S minus U, it gives us 11.375 thousand cubic meters. So again, we can realize here that of the 17.5 thousand cubic meters of water which is being received as rainfall during summer for agricultural land use, only 11.375, a major portion called 11.375 is converted into surface runoff, and we are left with very less water for the utilization. Likewise, for monsoon, we see here that the maximum rainfall is being received in monsoon season, which is 2000 mm. Now you can see here, since it is 2000 mm, the amount of rainfall which is received is 700 TCM. Now compare it. For winter, the rainfall was 35 TCM, which reduced to 17.5 TCM during summer. But for monsoon, it is 700 TCM. That is what I was trying to convey from that table, that the amount of rainfall is very, very high in monsoon as compared to summer and winter. So this is the amount of rainfall which is received, of which 25% is the storage. So you can see here that the storage is 175 TCM. That is possible. And this is the unutilized water, which is 175 again. So you can see here that the unutilized water is also very huge. So if we can come up with some provisions to utilize this unutilized water, which is 175 TCM, we can solve so much of the problems. For example, you see here that in summer, we are having the storage as nothing, and runoff is as high as almost it is. We can, if we calculate 11.375, how much is this representing the total precipitation? It will be somewhere around more than 85%. So this much is the water is becoming surface runoff, and we have this much water as unutilized as well. So might bringing some or taking some steps at this allow us to look forward for saving more water. Okay. Likewise, if we look forward for the last season, which is post monsoon season, we see here that it is 500 mm of rainfall which was received, and we found that the rainfall magnitude becomes 175 TCM, storage is 26.25 TCM, and unutilized rainwater is 35 TCM. So substituting all these three values in our final equation, which is P minus S minus U, it yields us 113.375 TCM. So one thing that we can conclude here is that the loss, or more specifically the unutilized water or surface runoff, taken together. So unutilized water and surface runoff. In fact, here we see here that the surface runoff is also a unutilized water for the present study area. So all both of them are becoming very significant. For example, if we add 35 in 113.75, it almost occupies more than 90% of the unutilized water from the rainfall. And this is the summary. So this is how actually the engineers, or more particularly those who deals with data, they come up with these kind of plots. And now we are also here, the policymaker, come technocrat, and we have studied the data from the previous researchers and now trying to decode some reasoning from them and trying to find out or quantify how the water scarcity problem can be solved. So this slide summarizes what we just now have seen in the calculations for winter, summer, monsoon, post-monsoon for agricultural land use. Here P is nothing but rainfall, S is the storage, U is unutilized water, and the yellow color here represents the surface runoff. So this diagrammatic representation allows us to gauge that the maximum rainfall is received in monsoon season, which is 700 TCM that we estimated, and we can see here that maximum storage is possible in monsoon followed by post monsoon, while hardly storage can be seen in winter and summer. And that's why imagining the second season for agriculture in the present study area seems difficult and challenging as well. But one thing which actually, makes us little uncomfortable is this huge amount of water. So, I mean, in the last lecture, someone asked this thing like, how come we are characterizing our present study region as semi-arid, although the rainfall is so high? So now I hope that the candidate must be having clarification to the question that was raised in the last week, that this is the reason that despite having high rainfall, the utilization is not clear and most of the water is becoming unutilized, yielding to water scarcity kind of conditions. Or we can say here that based on this graph, there is high chances that due to this high rainfall, flood kind of situation will be occurring in the monsoon season. So if this water is not managed properly, this huge rainfall can cause flood during monsoon, which can again disrupt our monsoonal agriculture. And hardly any water is available in the winter and summer, so we can imagine here that there is a drought kind of situation can occur. So this graph is actually giving us idea that how at one point of time flood situation may occur due to this huge rainfall and being unutilized, and how due to the acute scarcity of water resources drought kind of conditions can occur. Any questions? Any comments? I mean, as of now, whatever we have seen, anyone would like to comment or will like to sensitization? Please let me know. Anybody? So we have with us. Okay. I missed the introductory session. Can I access the recordings? This is an important session for me. Sure. Farha, this is a recorded session. So definitely these all recordings will be shared by NPTEL and you will be getting all these recordings. So no need to worry at all. But what is more important for me here is that are you able to understand whatever I am teaching right now, and whatever the questions that are there in your mind, please come up with. Ask your questions here such that, but surely if you post your questions on the forum, I will take care of all those questions in the next week, that is week 3. Moving ahead. So I mean those of you who joined late or those of you, yeah, anyone would like to say something?
So that is a part of week 2?
Which one?
Sir, yes, the topic that is visible on the screen.
Yeah, we are currently in week 2. Gentlemen, we are in week 2, we are done with week 1 lecture, right? And week 1 recording will be available soon. This is the week 2, and this recording will be again available to you. So you can surely watch week 1, followed by watching week 2, and then that can give you all the possible information about how we are actually taking steps to solve a water scarcity problem in one of the dry villages, or in one of the dry lands of India, which is eastern Maharashtra. So here, this slide where I am right now is, we reached here after solving, or after taking into account so many considerations from the village point of view and from social sciences point of view as well, alongside utilizing the information, hardcore information from engineering hydrology. Now, some of the findings that we can see here is surface runoff is the most dominating process. Yes, we can see here that this R is always dominating next to rainfall. So rainfall is the input, but output of the system is very high, which is surface runoff. So that's why we were discussing repeatedly in the week 1 that can we look forward for harvesting this runoff. So if we can harvest this runoff, maybe we will come up. And one more important thing is, like, we cannot utilize this unutilized water, which is red in color. This red color indicates unutilized water. So it is unutilized. Why it is unutilized? Because that we cannot really utilize it. For example, evaporation. Evaporation is a natural phenomena. So we cannot, we would not look forward for preventing the evaporation, such that the hydrological balance should be maintained. Also, this unutilized water includes evapotranspiration or groundwater infiltration. So we know that there are no scopes in the present village to extract groundwater resources. So these are waters which are unutilized. So we are not looking towards unutilized water. We are looking towards how this surface runoff can be harvested, because this is the scope. This is the only water that is available to us as a technocrat, as a policymaker, that we can look forward for harvesting through some policy implications, or through some modification that we can come up in the village in the form of, say, integrated watershed management, etc. Another thing is, like, more than 70% of the rainfall here is unutilized and part of surface runoff. So you can see here more than 70%. So the agricultural land use is merely dependent on less than 30% of the total water that we are receiving. So that's why the agricultural practices are somewhere getting challenges in the form of very less water availability, and that's why looking forward for growing crops, water intensive crops, is a bit challenging as well. And that's why we are limited to one season, because by the time we reach other season of the agriculture, that is Rabi season of the agriculture, we are out of water. So I have done this calculation for you for forest land use. However, this is supposed to be done by you. So I expect that all those enrolled candidates, you should solve and find out the values of surface runoff for each of the season for forest land use. However, I have done the same, and you can utilize this slide to verify when you will be doing this calculation. Here also we can see the similar story as of the agricultural land use. For example, here surface runoff is again the very dominating process, just like agriculture. And when I say surface runoff, it is this yellow block. You can see here the yellow. In fact, the yellow block was not so high in the case of, say, agricultural land use, but here it is far greater. And yeah, we can see here that more than 90% of the rainfall is now unutilized, or the part of surface runoff, which was merely 70% in case of agricultural land use. Not merely, but it is again very huge, which has increased in the case of forest land use. So we can see here that in the forest, we are unable to harvest surface runoff. I mean, some kind of provision should be done. Forest management ideas or strategies must have to be developed such that we can prevent, or we can store more water in the forest land use itself, or such that forest land use storage can allow us to utilize that water for many other applications such as agriculture.
So,
Yeah,
sir, in exam we have to see just like assignment questions or something else.
yeah. So this is problem solving session. The purpose of the problem solving session is to make you aware about how practical problems from water society sustainability course, or in general from humanities and social sciences, can be solved. So this has nothing to do with your examination. So whatever we are taking in this problem solving sessions, this has to do nothing with the regular exam of WSS, Water Society and Sustainability. So whatever the assignments that is being given to you, weekly assignments and weekly lectures that you are watching, that is the syllabus of your final examination. Whatever we are doing here is in addition to what that course can offer. So NPTEL for the first time from this season, they have started introducing problem solving sessions on a weekly basis, such that all the registered candidates should also get the benefit of realizing the theory of humanities and social sciences through problem points of view. Did I answer your question, gentlemen?
Yes, sir, but in general, I'm asking, uh, I have the NAPTEL first course, but I have not knowledge about such exams or as such assignments.
Okay,
In
okay. No
general,
worries. I suggest you that you should visit the course page of Water Society and Sustainability, and all the details of this course and how the NPTEL is actually taking courses, or what are the ways with which the course goes across a semester, that is being described there on the course page of NPTEL. More specifically, Water Society and Sustainability. The course code is HS117. So you need to search Water Society Sustainability HS117 and you will get all the information.
so could you write in the chat box?
Right. Yeah, I will write later. Similarly, we can see here that in the built-up plant, the runoff is way, way higher than what we have seen in the forest. Right? And that's why we have, if we can see here that the runoff part or the unutilized part is, I mean, comprehensively they are more than 95%. So that's why I mean, this is resulting in the low water storage across all seasons. In the case of built up, and that's why we in the week one we came up with. I mean, we expected that maybe rainwater harvesting could be a solution, but now from looking at this figure, we are pretty certain that there is a need of bringing a rainwater harvesting scheme to solve the or to at least increase the storage capacity from the built up land use, because here the unutilized part or the surface runoff part is very significant as compared to other land uses. And this is the lake. The lake or the surface water storage structure in this village is the only hope. And we can realize here that how, I mean, the other three land uses you see here, agriculture, forest, and built up, they almost followed similar trend. Wherein we found that the runoff part was increasing from agriculture to forest to built up. But when we look carefully for the lake land use, it is very less. I mean, it is very different. It is very different. So surface runoff is very less in the lake. So, I mean, one inference that we can draw here is if runoff is not significant from lake, then one thing that we can do for the lake is, can we increase the storage capacity of the lake? That is the only option left. So, and that's why we came up with the solution of a desiltation of lake, where we would like to remove the deposited silt or soil from the lake, from the base of the lake, and can increase the storage potential of the lake. That is the only option left with us, because from this graph we can clearly visualize that the runoff part is not so dominant, or the unutilized part is not so dominant, and uh, and we can find here that most of the water which is being received in each of the seasons are able to be get stored by the lake. So only option that we are having is to increase the storage capacity of the lake, which is what I am inferring, and definitely you may be having some more inferences that you will be writing to me via NPTEL forum. But any question?
Good afternoon, sir.
Yeah, good afternoon.
Farhat this side. Yes, sir. Sir, I have one question. Since you have said that rainwater harvesting could be an alternative to store the water, but in states like Delhi or in the northern region, we are not seeing enough rainfall happening right now. Southern region receives good amount of rainfall, like we have cities Bangalore and all those cities that we are seeing flooding happening in the southern region. but in northern region we are not seeing enough rainfall happening this season. So what all other options uh, can we employ apart from the rainwater harvesting for the storage?
Okay, so I mean, whatever we have been doing as of now was looking at the village landscape. So we were trying to find out the annual water budget in the week one and seasonal water budget in the week two for the village context. But you have brought here the urban context. You see that the urban context very differently as compared to village context. In village context, we can see here that the most dominating land use is the agriculture, right? So
Yeah.
here we were trying to, because here open space is more. You see here, agricultural land is having 35 hectare area, which is the most dominant land use in the village context. But when we go to urban context, then I mean, do we find agricultural land? If even if the agricultural land is there in the urban, it will be there at the outskirts, at the periphery, not at the heartland.
Yes, sir.
The regulations are completely different. So, I mean, whatever the question that you have asked requires separate lecture delivery, right? That requires separate lecture delivery because managing water resources in the urban context requires different knowledge and different ballgame. But now we are actually into village landscape. So can we stay here in the village and try to solve problem of a village first? And surely I will take care of whatever the question that you have asked for urban landscape. We can discuss this in the say in the next to next week. That is week four. In the
Sure,
week
sir.
four, I will try to in the week four I will do this experiment. What I will do is in the week four, I mean, we will be having all these solutions that we have developed for this village, and then I will try to bring some case study of a urban area, and try to compare that whatever the solutions that we propose for village, how they are differing from the problems of water scarcity that is occurring in the urban context. So we may be able to better appreciate how we are actually taking the approach of solving the water resources and how water is being stored or the scarcity problems is being solved in the urban context. Will that be fine?
Sure, sir. Sure. So, just one more follow-up question. Since the agricultural land is more in the rural areas, then there are chances of, for instance, fertilizers and pesticides going into the water, such as lakes and other water bodies, will lead to contamination of water. So how, since I don't know if this covers the quality of water the course covers, but this is the question that I have, because there are a lot of issues with respect to the usage of pesticides and fertilizers. So how do we really balance like this aspect of the development in the rural areas?
Right. It's really interesting, and both the questions that you asked were really interesting. So yes, that's why I mean, in the problem statement, I'm confining ourselves. Like we are the people who are looking forward for finding the budget of the water. So what is the water budget in the village? So when we say budget, we are looking forward for the quantity. So we are
Sure.
focused more towards the quantity of water in the various forms, maybe in the form of rainfall, in the form of storage, in the form of surface flow, and we hardly bothered about the quality aspects that you have just now asked. So maybe that is another scope that we can look forward to. But currently, the task that has been given to us, because what is the objective? Why we are doing this practice? Because in this village, what is more important for the villagers is not the quality of water, it is the unavailability of the water. So in this village context, we can clearly see here that the farmers or all the stakeholders are looking forward for more water availability. So that's why we are trying to look up how can we increase the storage capacity of the water by understanding what are the avenues of water available in the village. But surely you are correct. If in this village, although agriculture practice is limited to one season that we can see here, is the monsoon season. But if they are indeed utilizing these chemical fertilizers, surely it will be interfering with the water quality. But water is not available, that is the point. I mean, we can look forward for quality aspects as well. But what about the quantity of water? I mean, we require some water as well to learn the quality of water. So as we can see here, that you see here, winter, summer, it is almost dry season. It is a complete dry season, or in more specific terms, it is leading to drought conditions. And looking at this graph, I can say it is meteorological, hydrological, and agricultural drought, which are simultaneously leading to social drought as well. So that's why when situations of water scarcity is coming up, uh, and in the context of what we have been discussing so far, uh, the quality is somewhere not being looked, at least in the couple of weeks that we have, that since the time we have been solving this problem. But yes, you are absolutely correct. So in the week 4, what we can do once again here is we can come up with one policy guideline, because since our objective was to find out how much quantity of water is available, how much is the demand, how much is the supply possible, and how can we manage this supply, demand, and storage. So this is what we as a technocrat come policymaker were supposed to propose. But meanwhile, we will also give some guidelines or some future scopes while submitting this report. And we can recommend over there that the quality aspects has not been taken care of. But still, we would be interested to know whether farmers are cultivating organically or they are bringing some chemicals into picture for increasing their harvest or increasing their production. Will that be fine?
Yes, definitely.
Yeah. And that's why, I mean, yeah, before only I tried to, confine the problem statement, because there are so many aspects. I mean, for example, the one you brought is like, how about the urban context? That you brought is like, what about the water quality context? So that's why we are limiting our context such that we can able to appreciate the technical aspects as well as the role of social sciences in better inferring the technical aspects or the data that we are having. Right. So with this, I come to some of the recommendations for water management. Right. So let me read. Due to limited agricultural water availability during non-monsoonal seasons. So yeah, here, apart from monsoon, we see that the water availability is almost very less, like post-monsoon, winter, and summer. So due to limited agricultural water availability during non-monsoonal seasons, cropping pattern can be decided through community interaction. That is one of the recommendations which is coming up. That we need to go and talk with the farmers and should ask them that which are the crops that you're looking forward to. Because if we look forward for having paddy for the second season as well, then we are really sorry that that much water is not available for going for the second season of cropping, that too for paddy. Right. So, and that's why there is a need for interaction from the people before they could, decide which kind of crops they would be looking forward to yield or cultivate. Second point, community-led forestation activities can allow harvesting more surface runoff and checking soil erosion and lake siltation. So, yeah, this is a very joint or very comprehensive recommendation, that if we look forward for more forestation or growing more trees in those regions where trees are not available, or the lands which are, uh, not capturing the surface water or the rainfall water, then we can go forward for growing more trees that can help us to also check on soil erosion, thereby lake siltation. So maybe by having these kind of initiatives, we can prevent the deposition of the eroded soil inside lake, and with which we can actually look forward for conserving the storage potential of lake. Household level rooftop rainwater harvesting can be proposed to enhance storage from built up land use, especially during monsoon season, because we know that it is a complete concrete land, it is cemented land, and we hardly have opportunity to store water over there. So one of the findings or one of the solutions could be the rooftop rainwater harvesting. So if we can come up or if we can use this harvesting technique with, say, Pradhan Mantri Awas Yojana, then it can be a kind of superb idea, like integrating rooftop rainwater harvesting scheme with Awas Yojana, such that certain more funds can be released and can support the villages to come up with this scheme as well, such that they can have their own storage potential in each of their houses. Desiltation activities can allow increasing storage capacity. Yeah, for example, we have seen here that if the forestation will be increased, surely it will prevent soil erosion and can prevent lake siltation. But we are also looking for desiltation. I mean, whatever the silt which is already deposited, we want to remove them as well to increase the lake capacity. Right. So, lake
Sir,
desiltation is
I have
also,
Sir,
yeah,
I have one question regarding the last 2 points.
last 2 points,
So
yeah.
first one, yes, the first one is related to rooftop rainwater harvesting. So do we have any rules and regulations? For instance, if we want to install it in the apartments where there is a common roof, which might not be really possible to install. So install rainwater.
One second. Can you please come a little closer to your mic? I mean, your voice is too low to be get heard.
Yes, sir. I'll write in the chat box. Give me a second.
No, you just speak. I'm able to hear, but you are a little away from your microphone.
I was asking about the urban areas. So, for instance, rooftop rainwater harvesting. If you were to install it in apartments, so where there is a community roofs, the common roofs, not the individual roofs. So, in that case, do we have any rules and regulations or the method to be adopted for rainwater harvesting systems?
Yes, I mean, there are some states such as Tamil Nadu which are coming up with some stringent policies that if you are going to have your house constructed, then installing rainwater harvesting scheme is mandatory. So if you look forward for their policy, their guidelines, then you can find out how, where, how much, with what capacity, under what circumstances, and under which conditions. All those things are actually proposed over there. What you need to do is to just find out research papers which are looking into drafting policies for rainwater harvesting. You can also look forward for many websites like Ministry of Jal Shakti. There are so many schemes which for which they look forward for conserving the water. So and definitely indeed in some states of India, these kind of regulations are coming up, and they are taking some peak as well. But as I told you, we are in the village context, so let us stay in the village for some time. I mean, we can go to urban area in the week 4. Okay,
Sure, sir. Sorry.
right. And another question from Lake
So
Dissertation
that's
is,
related to lake desiltation. That's in the rural area, in the context of rural areas only. So when we desilt the lake, is there any ecologically friendly method of desilting, or just like we do it with machines and all those procedures that are being used? Is it like ecologically viable? Because I read an article, the way you desilt uh, can also have an impact. You might be desilting it for the purpose of removing the silt and just let the water flow freely, but it might not be ecologically viable. So I'm not really sure what like exactly should be the method for desiltation.
right. Very interesting question. No doubt about it. So, for example, if there is a siltation process occurring, that means the silt is being deposited at the base of the lake. So, one advantage that we get is that it prevents the flow of water from surface to groundwater. Exactly right.
Yes, sir, right.
Yeah. So with that, what we can do is, like, since the groundwater infiltration scope has been decreased because of the deposited silt, so we can have more water to be stored over the surface. That is one addition, because we have seen here that in this village, hardly groundwater acquisition was occurring. So one thing is very clear, that the supply of water in this village is mostly either from rain or from the surface storage such as lake. So we cannot allow lake water to infiltrate inside the ground, because provisions of bore well, tube well is not there in this village. So we wanted more water to be there on the surface. That is one solution. So if we desilt the structure, so we need to find out first of all what is the depth of the silt which is present in the lake. Once we identify, I mean, we can have a small hole, and then we can find out from there that how much is the depth of the silt available. So we not supposed to remove entire silt, but we can keep a certain layer of the silt intact, such that not much water should go inside the ground and more water should stay over the surface, because in this village the water utilization from the surface is more. That is one approach. Another thing that you added is like ecological implications, etc. So here in this context, since it's a village And the silt that we are actually taking out from the lake, so it is not a river first of all, it is a lake, it is a confined storage structure over the surface. So if we take out the silt from the lake, that silt can be reutilized as agricultural soil, so it can indirectly help us to improve the agricultural yield. Because since we know that the surface runoff in this village is very high, so the high quantity of rainfall, maybe have with the high intensity, will be taking away or will be eroding the surface. So under such circumstances, this deposited silt could be a very essential source or a fertile source for agricultural soil. That can be another use. So since we are in the village and this is the lake and not the river, we do not find any significant ecological implications of conducting the desiltations. Also, since one loss that could have occurred is the groundwater infiltration for the village. Again, that could become the unutilized water. So if we thoroughly desilt the structure, we will get large amount of silt. That large amount of silt can be utilized for agricultural purpose because there is a ample land available. So that is indeed useful for the village. But the storage then could not be retained because now the groundwater infiltration will increase like anything. Because now there is a scope of water to infiltrate inside the ground through the soil pores. So we also want to keep that soil pores little blocked because of this silt. So did I try to answer your question?
Yes. Like, is there a myth? For instance, it's an interesting point that you made that we have to check how much we want to desilt, because since we want the water to be there, not to go into the ground, we have want it to be there on the surface because that's the main source of the water for the village. So there must be a criteria for that as well. Like, how do we do that? Since I'm not aware about the technicalities of all of this, so I'm curious to know about that.
Yeah, I mean, there are so many like papers which are being published, or so many reports are there which discuss about how the desiltation should be taken care of. I mean,
Sure.
while solving this session, I mean, when we are in this session, our scope is to come up with these ideas. Right? Can we propose these ideas which are available to us, and then there are some agencies that will take care of. For example, since when we are in week 2, we are technocrat, so we are technically analyzing the problem, and we are policy maker too at the same time. So we are coming up some policies. So we came up with this fourth policy, say that the lake desiltation activities can allow increasing storage capacity. So please, there should be some frequent activities leading to lake desiltation. Say every year, at least once in a year, this should be done. So then, I mean, for example, in the summer season, we can conduct desiltation. Why? Because in the summer season, we do not have, in the lake. Yeah, this is the lake. In the summer season, we can conduct desiltation. Why? Because there is no water available in the lake. Right? Where is the storage? Storage is this one. Very less storage in summer. So summer season provides opportunity to harvest or to desilt the structure such that as soon as the monsoon will come, we can have a large amount of storage. And we all know that the groundwater infiltration rate is not so high as compared to how the surface water will be extracted by the stakeholders. So yeah, coming back to your question, I mean, definitely we can look forward for desiltation through many approaches, and there are so many guidelines available within which. So you can surely go out and check out how the desiltations are being taken care of. In general, there are a couple of schemes. For example, Mahatma Gandhi Narega scheme is there, uh, which is under Ministry of Rural Development. So in this Narega scheme, Mahatma Gandhi Narega scheme, National Rural Employment Guarantee Scheme, sometimes these kind of projects are being taken where they provide employment to the wagers or to the unskilled laborers, where they manually extract this silt. So I mean, if you look forward for finding the various works which are listed in Mahatma Gandhi Narega, then you can also find out how the Narega scheme is taking into account the desiltation projects of surface water storage structures such as check dams, lakes, etc. Did I answer your question?
Yes, sir, it's clear. Thank you.
So yeah, at the end, I mean, if anybody would like to give some more comments, I mean, the way the lady asked me some questions which actually provoked this discussion, no doubt. I mean, I'm really happy that the discussion or the problem that I understand that it was the hypothetical problem, but the kind of approaches we are taking into and the practical side that we are looking as well is giving us so many understandings about how we can actually manage the water resources. So, any comments? Any quick comments? If not, then let me give some teasers. So, as far as the week 1 and week 2 were concerned, we focused on annual water budget calculation during week 1 and focused on seasonal water budget calculation during week 2. And your homework for coming out from both week 1 and week 2 is try to find out the water availability like storage, surface runoff, rainfall, etc. for each of the land use. For example, one I have already solved, which is the agricultural land use. So by looking into how the actual land use calculations were conducted, you can try solving the other land uses as well to find out how the water availability status is there. So that is what we have done during week 1 and week 2. But again, there are some things which are still left over. For example, did we try to find out how much is the agricultural water demand? If they are growing paddy or if they are growing wheat, then do we know that how much is the water required for cultivating paddy or cultivating wheat? We didn't ask this question as of now, and we are a policy maker as well. So, and we are technocrat as well. So we never asked this question as of now. So by solving week 1 and week 2, but yes, this is the unsolved part. That how much is the demand for agricultural crops? Likewise, how much is the domestic water demand? There are people who really wanted water to drink, or they want water to cook, or they want water for bathing. For those purposes, where the water is coming from, right? Because we now know here that this village is located in such a place where municipal water supply is not available, or there is no pipe water supply available. So definitely, these lake or the rain, these are some of the sources which are there for them to meet their water. But we really don't know what is the demand. Likewise, since it is a village, we are pretty sure that bulls, cows, poultry farming must be there in the practice, and they will surely require water. For example, if you see in the rural areas, the human water demand is usually 40 liters per capita per day. It is assumed 40 liters per capita per day. But if we look for livestock, their water requirement is 60 liters per capita per day. So if livestock water demand is taken into account, the water demand for them will be way too higher on a per capita scale as compared to human. Surely, we have been repeatedly talking about the institutions, the villages, like schools, like Jila Parishad School, Sarpanch building, or say playground or any community halls, etc. There can be many other avenues or kind of institutions that can be there in the village that may also require water. Did we ask this question? That how much these institutions need water apart from the domestic needs or apart from the livestock water needs or apart from the agricultural water needs. So we never asked how much is the demand in the village. We have been looking forward always to find out what is the water available or how much is the water flow away from the surface. But yes, we have solved or we have identified one dimension, which is how much is the water available. So now we know that in this village, how much is the water available through the calculations that we did during week 1 and week 2 against each of the seasons. Now we are interested to find out how much is the water demand. And once we know both this dimension, that is the water availability and water demand, then the difference between both of them will give us whether this village is water surplus or water deficit, or under which season water was surplus and under which season water was deficit. And based on that, we can come up with more robust recommendations that if the water is deficit in so and so seasons, so say for example in summer, definitely I'm pretty sure that there will be deficit water availability. The demand will be very high in summer, but the availability of water will be very less. So we will be finding negative value over there. Then how we are coming up with the recommendations? Because therein we know that this much of the amount of water required, and based on that, how we can actually bring that water in the village of that particular quantity. So that's why we need some technical information as well. That because technical information usually provide us lots of idea or lots of data or quantity. And once we know the quantity, then we can look forward to find out where are the sources available to fulfill this quantity. So that is the part that we will be looking forward in the week 3. So I request all the enrolled candidates and those who are watching this video on YouTube that you should do join in week 3 and also look week 1 and week 2 lectures. Once we are done with solving or finding all the water availability status with regards to storage, supply and demand, then our interest will be more towards designing the decentralized water management system that we will be looking forward in week 4. So any quick comments or questions? No questions? Okay, so with this, we will wrap up the today's session, and I will look forward to meet you in week 3 and subsequently in week 4. And whatever the ideas or some of the suggestions that I received today will be surely accounted in the subsequent weeks. Thank you.